have the presentation by Mr. Vijay first, and post-presentation we will start the panel discussion. Over to you, sir.
So my fellow panelists and dignitaries, good afternoon. I think with heavy lunch and having good sweet, I think this session will try to keep your walk as tell by Mr. Organizers. So the topic efficient and sustainable water treatment is very crucial for industrial sustainability in relations with growing water scarcity, cost of water, and stringent environment norms and the treatment cost. No longer we can view water as a utility to be used and only discharged. We have to reuse it. I understand we all are working in our industries for sustainability, for minimizing the waste consumptions, maximizing the reuse, recycling in process, and related energy consumptions optimizations. We are looking towards newly technologies and its implementation that are effective, environmentally friendly, and economically viable. Continuous improvement is a need of water and wastewater treatment. That is, as we follow in our IMS setup also. So continuous improvement is needed. Why? So we can have the water consumption optimization, as we are discussing in the previous sessions also. We have to reduce our water consumptions, our environment footprint year by year, and have to make system more sustainable. In OPAL, we have faced plant load reductions in 2018 during water crisis. We have, based on that, we have participated in 100 MLT desalination plant brought by the GIDC as a major consumer. As a newly plant for design concepts, already by our EIL and main consultant, have considered lot of improvements based on the learning from the other industries. So our setup is already having a very good amount of, you can say, very low footprint. But even then, we have faced challenges as a petrochemical complexes. So I want to just brief those challenges and what solutions we have used in our setup. So I made some few slides on that one. So that will cover the total topic point from OPAL perspective. This is just a brief about the OPAL. OPAL is a subsidiary of ONGC. This mega petrochemical complex was dedicated to nations by our Honorable Prime Minister, Mr. Modi, in 2017. This OPAL is a dual feed cracker unit having 1100 KTP of ethylene productions and 400 KTP of the propylene productions. And based on that, our total polymer production capacity is of 14 lakhs tons of the polymers and 5 lakhs tons of the chemicals per year. To support this cracker and polymer unit, we have a dedicated utilities and offsites having 195 megawatt power plant, a detailed very vast effluent treatment plant. Just to say that the cost of that effluent treatment plant is 170 crore. So that is a very big effluent treatment plant associated with the setup. Now, just to give an idea to go before the challenges, what setup we are having it. We are having ultrafiltration based a new raw water treatment plant, which is having chlorine dioxide as a microbial control. Then we are having this use of this treated water in our 3 cooling towers. Then we use for our DM plant and service water as the normally all industries are having it. But to know the quantum of the water usage in the cooling tower, around 80% of our water is being used in the cooling towers, around 9 to 10% in the DM plant, and the balance in the various other utilities. So the big chunk is cooling towers. So in OPAL, we have given more thrust on cooling towers, water consumption optimizations. So in cooling tower, from the basic design for microbiological control, only chlorine was considered as a non-oxidizing biocide. In effluent treatment plant, we are having, as I told, that big plant, 1150 meter cube per hour capacity we are having it. So we treat it here, all the cooling tower blowdowns, all process waste, oily water. So, and all this setup being treated and all water is recycled to the cooling tower. So in our setup, we recycle approximately 90% of the waste, our blow down which we are generating in the setup. Only balance 10%, which is having mainly our DM plant effluent, is being discharged through GIDC in the deep sea. We are having the rainwater recovery setup. So all floor washing in our plant are being treated and again recycled to the cooling tower. So that reduce our fresh water intake from the setup. We are having the sanitary water treatment plant, as normally other industry also having it. And our total pre-treatment process is based on the UF, RO, and microbiological reactors are there, SBR and ACT, for treatment of reduction in the COD and other setups. So these are the challenges. First is in 2021, we faced that our one exchanger leaked in our cooling tower, in our DF2 cracker plant, that affected our main cooling tower. Second is we are in effluent treatment plant. We are getting a lot of microbiological, you can say, contaminations that was affecting our ultrafiltration and RO setup. So our recovery was less and our downtime was very high. And also, as chlorine being used in cooling towers, so as it is a hazardous chemical, so when there is a leakage in our cooling tower, so we have started to increase the doses. And after increasing the doses 3 times, our chlorine turner connection disconnection activity comes in every shifts, or you can say in the after 2 shifts. So that increased the risk of the handling in the setup. So how we have managed this situation in 2021? Because normally as a petrochemical complex, every shutdown cost very high. So as a usual practice, we take shutdowns in every 5 years. So last shutdown we have taken after the plant dedication 2017 in 2022. So in the 2021, then we have faced when our propylene condenser leaked, and that leakage contributed our organic loading in the cooling tower circulations. Our plant capacity limitation we faced. So to maintain those ORP, we have introduced, to maintain that ORP, we have to increase our chlorine doses. And with that one, the total chloride level increased in our chlorine tower blowdown, which is going to our effluent treatment plant. With this increase in the chloride level in the blowdown, we need more intake water, and our water consumptions grown up at that time. Also, with this blockage and you can say the organic loading on the exchangers, we are facing the problem in other exchangers, but we had managed at that time, and we had taken the shutdown in 2022. So to handle these situations, we have introduced chlorine dioxide. Normally, it is being used in fertilizers also from many years. But as the cost of this treatment is very high, because approximately you can say, if you see the equivalent terms basis pay, 4 to 5 times the cost of chlorine dioxide. So we have optimized that process. So we have used one pump method and mixed chlorine and ClO2. And with that one, we could able to reduce our chloride levels in our cooling towers. And with that one, the total our intake water consumption have reduced drastically. And based on that, we have saved crores in our total treatment process, because with that one, we had increased our COC levels and our improved in the quality of the cooling towers. Our slime deposits on the pillars, on concrete pillars of the cooling towers, because we are having very big cooling towers, 80,000, 40,000, 20,000, as I mentioned in the previous slides. So to maintain those cooling towers, that slime was also affecting our total performance of the setup. Now, second, that is what I told that regarding that our RO pre-treatment that is high microbiological MIC attacks जो हुआ हमारे system के अंदर में. Actually, as per design, our cooling tower blowdown line, which is going to ETP, is 3.5 kilometer. So you can imagine that line, if you're maintaining 0.5 FRC even in our cooling tower, and having the very detailed treatment program. Even with that one, we could not able to manage the inlet FRC or inlet chlorine at our effluent treatment plant inlet. So with that, what was happening, there is a very high amount of microbe growth in our high rate solid contact clarifiers. Our pipelines was getting MIC attacks and increase the downtime. Our UF, as you know that UF membrane is very costly. So we were getting only the life of 6 months only. So there was a huge impact was there. And with that one, we initially started to handle it with the hypodosing at the setup. But as our high rate solid contact clarifier pH is on higher side, it is in the range of 11 pH. So those hypo was also not working it. So we introduced the chlorine dioxide. And with that chlorine dioxide dosing, I show that before what we are having the setup and now after that CO2 dosing, the total greenish water changed to bluish water. Lot of vegetation was there. So now we are getting a good feed for our RO setup. So after, even with the ultrafiltration outlet, we are able to maintain 0.1 ppm of CO2. And with that one, we are getting a very good quality of the water in the setup. Now to the topic regarding that sustainability, as I told that continual improvement is there. So from the design itself, our raw water reservoirs, which are having around 4 to 5 days hold up, and capacity of 1,25,000 into 2. So that is covered. So with that one, we are having, you can say, near to zero evaporation losses from the cooling towers. With the dosing of CO2, we have improved the qualities. We have worked on our cooling towers to reduce the windage losses, because as a coastal, there is a very huge amount of, or you can say very high velocity of air is there. So lot of water was coming out from the towers. So with the maintenance and increasing the blade angles, and then the end of the both side cover 50% with the FRP sheets. So we have reduced the water from the loss from the cooling tower, and that water we are recovering through ECTS. So our water in the drain and again collecting back to our ECTS reduce sustainability. We are recovering 90% of our cooling tower blowdown, and all our off-spec condensate, if it is generating in the process, we are recycling to the cooling towers. With this, we are able to operate our cooling tower at the higher COC, as I told earlier. We are recovering the rainwater. We are close monitoring our total water distribution setup. We are maintaining, as all other industries also doing, that water balance. So with that, we are able to manage our intake, the total setup. This is from my side, that what we have done on OPAL. Thank you.
Thank you, sir. So, for the next 30 minutes, we are going to discuss about the importance of integrating efficient, sustainable water treatment in chemical plants, petrochemical plants, to conserve resources and support long-term environmental goals. So let me begin with Mr. Desai, and this question is for all three panelists. So, sir, what are the challenges in efficient and sustainable water treatment for chemical and petrochemical plants in India?
Good afternoon. Are you getting me? Okay. Since morning, we are talking about various subjects, but it is related to environment only, whether it is a renewable energy or ESH or waste management, and what was some balance Mr. Rajeev has completed. Therefore, so far as challenges is concerned, I will talk only non-technical challenges, which are very much practical on floor. I will explain zero liquid discharge or the challenges without speaking. It is like this only. This is the niyat. Niyat ही नहीं है, no intention. ETP is the area to manage, not to operate. Please forgive me if I am speaking much, but when we are speaking about challenges, The whatever I have seen in my 44 years at various stages, whatever seminar, webinar, everything what we are doing here, it is a vibrant subject. But the moment we go to plant, production and quality is the first priority, ETP is the last priority. This is the bitter truth, whether you agree or not. I will give a small funny joke on this. It will give my insight. There was a big organization, they decided to recruit ETP manager, environmental manager. And they scrutinized all the applications. They decided we'll take only PhD fellow. They selected only 3% for interview. On first candidate, they called and then asked, 5 into 2, how much? Then he shocked. I am a PhD person and he is asking 5 into 2. I don't want to work in this organization. What is the level? He is told, excuse me. He went out. Second person came. Same question was asked. He shocked, but not so much. It is a part of life. Then he saw and 5 into 10. And third person came. And then third person came. 5 into 2, same question was asked. He was delighted. Then he stood up. Then closed the door. He closed the door. And धीरे से जाके कान में बोला, how much you want? I can do it. Panel, the person who is sitting outside on waiting, second candidate, उसको बोल दिया तुम जा सकते हो, हमको candidate मिल गया. This is the real challenge, whether you accept or not. ETP is concerned as a cost center, not as a service center. The person who can do best liaison with inspectors is the best environmental person. This is a real challenge, whether you like or not. In one I will take few minutes, but see, I told you I will not speak anything about technically, but what is happening on floor. In industrial estate, there is a concept of common effluent treatment plant. Hypothetically, I am talking about, don't take for any particular industrial estate. 500 industries were there, and total load on CETP was 30 MLD. GPCB, CPCB, whatever you say, they imposed, and 15% industry were back, zero liquid discharge. CETP, inlet, 30 MLD. Slowly, only 15% were left. Balance all the industry will come, zero discharge, CETP, 30 MLD. That means, what is the definition of zero liquid discharge? Mode of discharge is changed. I cannot speak much, but you have understand. This is the challenge. Right? This is the challenge. We should understand that we are not owner of the natural resources, we are custodian. Yes. हमको खाना है, मेरे सन को बोल दिया कि मैंने खाना खा लिया है, तेरे लिए जो बचा कुचा है डाइनिंग टेबल रखा है, जब टाइम मिले तो खा लेना. This is what we are doing today. But what is sustainability? बेटा खाना आ गया है, तू खा लेना, जो बचे वो मेरे लिए रखना. That is sustainability. We should not consume everything. हमको next generation के लिए कुछ देखना है. Now, so far as plant is concerned, whatever technology we purchase, very know-how, German से लिया, France से लिया है, but वो ढंग से operate नहीं होएगा. Then deviation will be there in effluent and you will be puzzling for better treatment. ऐसा क्यों होता है? There are so many reasons, but one of the reasons what I have seen in public sector is we are recruiting skilled operators, but in real practice, because of association and union or whatever you say, they remain seated, mobile playing, sleeping, and plant is operated only and only by casual laborers. Under the protection of union or association, whatever you say, I am once again apologize if you आपको कोई बुरा लगता है, but I am speaking the real truth. Indians किसको बोलते हैं? They are very much clear about others' responsibility. Public sector के operator को तुम पूछो तो they are very much clear what you should do. पर तुमको क्या करना है वो मालूम ही नहीं है. Whenever responsibility is coming for operating the plant, he will pass on the buck to some other. अरे तुमने बोल दिया उसने कर दिया वो हिंदुस्तान नहीं, करने की 100 तकलीफें, नहीं करने के 1000 बहाने, वो हमारा हिंदुस्तान. ये सब मेंटालिटी की वजह से कोई भी टेक्नोलॉजी हो, if SOP is not there, TQM, total quality management is not there, industrial discipline is not there, the quality of effluent will be definitely going to be deteriorated, and we are not going to treat properly. This is one of the best challenge as per me. There are so many things on technical ground I can speak, but time is limited, therefore I will not speak much. Thank you very much.
Thank you, sir. You spoke on the very surface level. Coming to you, Mr. Joshi, how do you see the challenges?
As very well said by Mr. Desai and technically explained by Rajeev. So I will touch upon on some practical things. As said by Mr. Rajeev that what is important, the SOP, before the session we were discussing, the today's challenge, which I also experienced that we got the people who are certified or you can say qualified, but you can ask them to go and work on a field, then they will ask a question like them, sir, 5 plus 2, how much? Give me calculator, I will work. So the challenge is that what are the work they are supposed to do? What are the technical capabilities or basics are required? That is the basic challenge. I fully agree with Mr. Desai is that ETP or any water treatment area should be the top priority, okay? Because utility is the heart. Without utility, chemical plant or petrochemical plant will not work efficiently. I think couple of challenges as Rajeev has mentioned, you were able to see what are the challenges that resulted into a lot of efficiency loss. So anything which we talk about loss is not going to come again because it's a time based. Manufacturing is a cyclic process. So if you improve something, it will circulate on improvement. If you lose something, it will continuously lose it. So technical capability, when I talk about technical capability, means basics know-how of the people and the process is very important thing to ensure that what we are working is the right thing. If coming back to certain technical things for the water, so water is being used mainly either the utility or some of the process purpose. So you need to treat the water basic treatment before providing to the process or utility. So those are also varying. Either water is coming for multiple sources or from the same source, but the quality is different. So you should understand, and online monitoring or periodic monitoring is very important thing. Otherwise, what he's just said, जैसे आता है वैसे जाता है. नहीं सर, सुबह 7 बजे भी वही रीडिंग था, दोपहर को 2 बजे जाने के टाइम भी वही रीडिंग. So log sheets are being prepared. What I would like to tell you, it is important we need to train our people in terms of what will happen if we don't do the right things. The basic example given by कि खाना आया है, मैंने खा लिया है, बचा कुचा तेरे लिए. So the important crux is that if we don't do the right things, what is the impact? That is one of the basic area we should look into this. I think we will talk much on this.
Yeah, come in. Thank you. So, sir, various challenges are enumerated, and like Mr. Desai or Mr. Joshi talked about SOPs. So, what should be the implementation mechanism to put the SOP in practice? And how industry as a whole is implementing these on the ground?
Normally in what we follow in OPAL, that is a validation process. So if a person, taking the working in other areas and coming to that area, panels, so he has to go exhaustive training on that process, and then validation is required. And that validations to be submitted to his senior person, and based on that validation we give the charge. But still, when for example we are working in OPAL, so panels mein we are having the OPAL employees, but in the field we are having the contract persons. So we are hiring the persons after doing the interviews and those processes, but their attrition levels, when they come, they leave the companies, after 3-4 months we have to work lot of for those trainings. So those affect our total operation setup. So that reduce the reliability, but Even with that one, we are trying, and I think industry is also doing that process. The training part is very much important. Even if the person leave the company, that has to be managed very strongly. And those processes, checks to be recorded. For example, some alarms are missing in the particular shifts. So those alarms to be witnessed or to be checked by the superior persons or shift in charge in that total 24 hours. Sometimes some certain missings are there, but these SOPs and processes are very much important. And one more things regarding that SOPs there is a changing in the water quality, as Mr. Keyur was telling it. For example, earlier we are receiving the water from the canal water. Then during summer, that water being pumped from those river bank. So chloride levels were shooting up. Now that desalination setup is coming. So those SOPs needs to be updated and to be again validated by all the engineers and all the persons. And main thing is that, as my co-panelist Mr. Keyur was telling it, if we have invested certain things in the setup, we have to maintain it, even if we are having the cost incurred for that one. So we have to do our, you can say we've taken that, if we have to maintain the setup, so that is important. Thank you.
Thank you. So related to this question, I am coming to Mr. Desai. Sir, companies are like implementing advanced water treatment technologies like membrane filtration, electrochemical process, biologicals are there. How effective are these new technologies, and are these technologies are going to be, like what you said, going to be implemented properly by the companies?
Thank you very much for good question. First, high COD is not the headache if it is biodegradable, because activated sludge process is economical, you can say, if you manage properly. Are you getting me or not? Yeah.
Yes, yes, sir.
But ammonical nitrogen, toxicity, heavy metal, and refractory COD. Refractory COD means it is not biodegradable. All these things are the headache or challenge, and how to cope with this type of challenge. First, do master degree on treatment. I don't say no, but do PhD to control pollution at source. That is most important. Whenever you have a problem of refractory COD, which is calling for advanced oxidation process, which is really costly and making your plant technically non-viable and non-feasible. First, you should say, if it is a plant site, you have to study plant-wise. If it is a big plant, section-wise. Isolate refractory COD or high ammonical stream separately and other stream are separately. Thereafter, you apply AOP, that is oxidation process, advanced oxidation process, not for full degradation. But see, there are a lot of structure, polymer structure, branch chain, cross chain, cyclic compound, all these complicated structure are non-biodegradable. Use AOP just to break the structure to make it biodegradable. Thereafter, you go for ASP, activated sludge process, BOD. Then your plant will be feasible and viable. If you want to apply everything on the AOP, just like there are a list of advanced oxidation process, it is really costly, right? But lot of advanced oxidation processes are available in industry, and practically those who have good niyat, they are really operating. I have seen micro filtration, ultra filtration, nano filtration, reverse osmosis, then electro-oxidation, electrocoagulation, then ultraviolet with TiO2 catalyst, then Fenton reagent, FECO, ME, MVRE, mechanical vapor recompression, spread air, ultrasonic sound, ion exchange. There are so many processes, but each and every process has limitation as well as advantage. But generally, if AOP is working very nicely, almost 95% contamination removal I have observed, and it is possible. Then organic heavy metal salts are removed very nicely, and whatever permeate in, if it is RO, you can definitely reuse either in cooling tower, or if it is a really good quality, you can use in process water back. Advantage is the less space requirement and very not time consuming. ASP is a very time consuming process, activator slash BOD process is. But all these AOP are working definitely efficiently if we are very much active. But there are some problems also, particularly in RO. Membrane fouling, selection of right membrane, what should be the osmotic pressure for my salt. Then if you are using electrocoagulation or electrooxidation, there will be a frequent erosion of electrode, it is very costly. Then if it is a ME, then your evaporator calandria will be choked with silica scale, and fouling will be there, and flow will be less heat exchanger. जितनी बार देखो तो 70% टाइम तो वो अंडर मेंटेनेंस अंडर क्लीनिंग ही रहेगा. All these problems are definitely there. Then if spread air is there, dusting will be the problem. If toxicity is there, bacteria, microorganism, MLSS, MLVSS, all it will die. There are a lot of problems. Therefore, we should be very rational. For when we apply AOP, we should be very rational, and we must have skilled operator to operate all the plant and to take total benefit of AOP with minimum cost and maximum efficiency. This is my concern. Thank you very much.
Thank you, sir. Thank you. Coming to you, Mr. Joshi, how water efficiency and reuse helps in reducing freshwater demand and thereby helping in process optimization, and how plants are implementing this?
Okay, so reuse, recycle, and reduce, the 3 R's, we all are aware about it. And that is today's need of the industry as we are talking about sustainability. There are very basic things are there, which is not even the industrial, but household or anywhere else also. What are we doing exactly? I will talk mixed, technical and non-technical. The important thing is that do we understand what we want to achieve, how we want to achieve, and the why we want to achieve. If these 3 things we focus, that will help us. Anything, I have seen certain companies, certain hotel or certain places where people are using their the split AC condensate water which is coming out, okay, for vertical gardening, okay, which is one of the very basic example of the wastage water. The purpose of giving this example is that we have to see from where the water, the energy in our plant is getting wasted, how we can recover it or we can use it in an efficient way. So better you recycle or reuse it for your process or the other purpose, that will reduce multiple stages. Means you will need a less fresh water requirement, maybe less fresh energy requirement. When you need a fresh water and want to supply to the process or utility, so again it need a pre-treatment. So if you have this recycled water available, which is already treated and which is very good quality, your processing time as well as cost will reduce. So this will also help in the benefiting the things. Otherwise, the water which is coming from outside or you pre-treating it, every time the cost is increasing. Second important thing is continuous process, operation and maintenance. So if you are mainly in utility, the water or the steam, the recovery of the steam, condensation, many times the steam traps are bypassed. Okay? How efficiently it is being managed, that is a very important thing. So the minimal day-to-day operations and maintenance, which is the basics of the things. So anything what we want to achieve, that is what I said, what we want to do, then we have to understand why we want to do, and then we should think about how we can do or how we want to do it. These are the 3 areas which ultimately help in our day-to-day cost, the time, the requirement of the fresh inputs in terms of direct energy or in terms of the indirect energy. When I talk about indirect energy, it is the time and the cost required to treat, manage those particular water or the energy and recycle it back to your system or the plant. Otherwise, what will happen, this will ultimately, as said rightly by my co-panelists, that many times these systems are very less focused. When we go to the plant or shop floor, focus is what is my output and quality. But the important thing is that it is like our body. We want to keep our health maintained, okay? So we should not every day check how my heart is working, but we have to see what I will do which will help my heart is working very well. So those are an important thing ultimately applicable in our industry also. If your equipment is there, how your equipment is running, what are the processes? One of the things I will say, in the treatment plant, there are two things. One is an input, either fresh water coming, so quality of the water. Second, in the treatment plant, what are the processed wastewater is coming. So when there is a deviations or a fluctuations in that particular process will affect your waste streams. And that will again come to your treatment plant. So your treatment capacity or the process should be either flexible enough to capable handle those challenges, or otherwise you have to upgrade. Many times you have seen your process has improved. There are a lot of improvement happen in the process. But what will happen, the effluent generated from that process, it goes to a central plant or ATP, you are not working anything for its improvement. Is there a latest technology? What are the changes happening? So that combination is very much important. Otherwise, there will be a misbalance happen. And as said by Mr. Desai, the first things then will go for it, which is not as sustainable. For the sustainable things, we should look into this, and that is what the process is very important. And in one of the question he asked an SOP, I will like to touch upon. In one of my organizations, when ISO auditor came first time, I'm talking about 98, 99, he said, I want to talk to your operator. So he asked a question, what do you mean by ISO? So he said one line, jo likho wo karo, jo karo wo likho. That is called ISO. So I think that is the best way, as Rajeev also said, that they have the contractor people at the shop floor, and the panel, they are the employee. So these are the two people in terms of their capability, knowledge, skills, everything. You cannot have a two separate process for them. You have to have a single process for them. So our processes should be so simple enough that everybody can understand. And the important thing is what we want them to do. If we write in a way they understand, learn and execute, that will help. Otherwise, that is the first step will create a difference between what you want to do and what exactly is being done. Thank you.
Mr. Vijay, what is your take on this?
My point is that what Mr. Keyur was telling it, that IMS. So what I want to say that audit is very important in our processes. So what treatment, for example, the older plant 9 years, 10 years, 15 years, 7 years are there. Even we are having the good technical knowledge persons are there. The third eye is very important. And to get the acquaintancy or to get the new technology exposures or what development have come, so those setups audits are required. So from there you can plug where those losses are going on. As Mr. Keyur is telling that is very much true also. In the process setup, if you are operating the panels or you are operating the main process plant or your tank farm setup, all locations, very tight control. So you can avoid the contamination in the OWS setup. So that will give the less load to your effluent treatment plant. And from that location, you can easily save your costly chemicals and then those processes, methods, what you are coming in the setups. Second thing is that for example, the plant is designed for certain capacities and setup. If you are improved the setup and you are now getting good efficiencies or you are less load on those treatment processes and those utilities areas, so you have to work on the energy for VFD of those drives, certain impeller trimmings, and also those chemical optimizations. For example, giving example, after the desalination water mixing in the GIDC water, the silica level came down. So with that process, the SOP is maintaining the same. For example, in our water treatment to remove that silica, we were dosing the dolomite. But after reducing that silica, we stopped that dolomite chemical addition. So that reduced drastic sludge generations and also saved the chemical also. So the process changes and process reviews are important to keep updated and to keep that system well maintained.
Good. Thank you so much. So what we are discussing, the cracks is coming that the plants are not so working in a responsible manner. So my question would be like how chemical and petrochemical plants are looking at the water treatment issue as an environmental and sustainability impact. Mr. Desai.
You're talking about policy.
No, not policy. How the plants or chemical companies are looking at the water treatment issues as a impact on the sustainability and environment.
See, sustainability and environmental impact is really a thing which we should be concerned by heart. There are three aspects: discharge of liquid, discharge of gaseous emission, as well as solid waste. We can see in nearby estate in night how much gas they are discharging, emitting without any treatment. Solid waste dumping, unauthorized discharge we are seeing. All these things are affecting not only human health, but they are also affecting the flora, fauna, and the animals and nearby vegetation also. Therefore, we should be very much attentive towards all type of waste. Production is definitely priority, but not at the cost of our future. That is my concern. And we should consider whatever expense we are doing on environmental treatment or waste treatment, it is an investment, it is not an expense.
Thank you. So my final question would be like, I'm starting from with you, Mr. Joshi. How can the industry, chemical and petrochemical industry, implement or bring global best practices in terms of water treatment in the practice? What should be the suggestion, all three of your suggestion to the industry?
See, best, I would say there is no one solution for all kind of the process. It will be based on the which kind of the manufacturing process or your process is there. So you have to work accordingly. Just if one thing remained in my mind, in one of the organization I have before 6 years, so I went to one of the vendor visit, which is well-known company, Mahindra. So Mahindra near Nasik, they have a plant, and when I visited for one of this kind of a conclave, it's called the vendor visit. So what I learned that particular plant become zero or net water positive, means they are taking zero water from the MIDC. So 100% self-sustainable. So this is itself is one of the way. But yes, that is a assembly line. They are not the chemical company, so the water need is also less. But what the way they manage it, the storing of the rainwater harvesting in such a fantastic way, plus the usage, the utilities what they need, particularly the water and chilling refrigerations, that was very well managed. When I say manage means in terms of the operation and maintenance in such a way, the effluent which was coming out, they have also the effluent treatment plant. And again the water coming out from that particular plant, so they use in the gardening and the toiletries and everywhere. The management of water was fantastic. So coming to our requirement, so chemical industry might have a challenge. They may not be a water or zero net, but the important thing is that what are the processes what you are doing it. I would say in that particular process, what is the right way to do? If you are following the design parameter, if you are following the right way of operating, strict monitoring, as I said, in terms of what is the requirement of that particular process, that really help us. So in today's world, there are a lot of best practices are available. We can use the technologies. Now AI is there. So we can make the use of AI and make more interactive with our people, so that they can able to see the things, they can able to immediate understand and take an actions on that, rather than just simply maybe an example, writing all the reports in the logbook. If they have a digital logbook, everything is being monitored, something get deviated, so that immediately highlighted, they take an actions. I'm giving very small examples of this. The important thing is How we manage our processes, yes, absolutely, you said what are the best practices, but as per me, the best practice is what is need in your industry, particularly in your process, that we should focus.
Thank you. Mr. Vijay.
There, I think two things are important is that the older plants has to review their system, and because new technologies are now in the process and well tested, so those new setups to be in a phase manner to be adopted, as I think in our previous sessions also, because how effluent we are discharging in outside, that quality is very important. So we have to strengthen our total treatment processes, and audits in the setup is a must for the continual improvement in the setup. If you are doing at any process, if you are operating some plant, processes, power plants, something, if you are having the continual audit process in your setup, then I'm giving that guarantee, you will see the lot of changes and improvements regarding that energy, sustainability, you will always achieve in your system.
Thank you. Mr. Desai, how you talk about the inspector and the government and the industry. What could be the monetary scheme or things? Yeah, incentives from the government side, and how government and industry can work together to address this issue.
MOEF CC, that is Ministry of Environment and Forest for Climate Change. Nowadays, whenever any new industry is going for EIA, while clearing EIA, they are putting condition for zero liquid discharge for category A and category B industries, not for all. If we talk about State Pollution Control Board, then particularly Tamil Nadu, they have mandatory instruction is given to all textile industry to make zero liquid discharge. Gujarat, while going for renewal of CCA, your CCA will be renewed if you commit for zero liquid discharge. In Maharashtra also they are doing the same thing. Nowadays slowly, zero liquid discharge concept is penetrating legally. But it is costly. Therefore, lot of subsidies, then grants, then bridge loan, soft loans are available. Grant like IIUS, Industrial Industrial Infrastructure Upgradation Scheme, then Technology Upgradation Fund Scheme, then CLCSA, Credit Link Capital Subsidy Scheme. There are a lot of schemes are available connected with your performance. If your performance is good, you will get lot of subsidies. Then if you go to the website of government, lot of incentives are available, lot of subsidies are available. This will tempt you and you can commit for environmental protection. Thank you.
So while you are telling that a lot of incentives are available from the government side, what is hindering these chemical companies or plants to avail those incentives? Is there not awareness?
Yeah, one is the technological constraint is there. The second thing, they are not fully aware what type of technology is suitable to my effluent. And third thing, subsidy is available 25%. Maximum, you may get 50% if it is a government company. The balance 50%, who will go for? Yes, there is one way to make PPP, public-private partnership,
Yes, sir.
for common effluent treatment plant. Particularly if it is an industrial estate, it is better way to adopt a concept of CTP, because standard to discharge to CTP is somewhat different. Then CTP will take care. Now to make zero liquid discharge CTP, almost 75% grant government is giving. But this knowledge is not available. And very frankly speaking, though there is no research or innovation on how to treat effluent. Lot of innovation is there in production, but research and जितना चाहिए इतना एफ्लुएंट पर रिसर्च नहीं किया है एंड इतना पेनिट्रेट भी नहीं किया है कि कितना सब्सिडी ग्रांट इज अवेलेबल. दिस इज द मेन कंस्ट्रेंट.
So, do you think that PPP model will help in tackling this issue?
Yes, certainly, because in our Dahej region, GIDC has come with the CETP treatment programs. So the industries which are having that effluent not meeting the norms, so they are discharging in CETP, and then those being further treated, then it will go to the deep sea. But I want to add one more point is that the plant who are having the very good effluent treatment plants are not getting a fully incentivized. As for example, in Opal case also, if you just giving example, what water we are purchasing from the GIDC or taking from the GIDC, only 5% we are discharging as effluent. But we have to pay the drainage cess, which is around 32 rupees per meter cube on the total incoming water quantities. So that is making the total system or water draw and all the process, even doing all our energy consumptions or 40 rupees our cost of effluent treatment per meter cube. Even with that one also, we are not getting incentive in our incoming cost. So we are getting the water at the cost of 85 rupees or 88 rupees. But we are only discharging effluent only 5%. So those loopholes are there. We have given a good representation in the GIDC also. But still that could not be solved. So but what your question is very much correct. Those industries, because making a small ETP is a very cost intensive. You are installing some UF and RO setups and for doing those bioreactors. So if the setup is in the common, and then those industries participate in that process, so that will give that good incentive.
Thank you. Thank you, sir. Just a minute. Yes, sir. Yeah, yes, sir.
My last thought regarding quality standard, effluent standard, 100 COD, 50 ammonium nitrogen, all these standards, what is the rationale behind that? What is the logic behind that? There are two fundamental concepts. One is prevention of pollution. Second is prevention of environment. Asian country, and particularly India, is very much interested in prevention of pollution. And all European country, it is a synergistic combination of two. Prevention of pollution as well as prevention of ambient. Prevention of pollution means environmental standard, what we are aware. That is ELV, effluent limiting value. And prevention of environment, that is EQS, environmental quality standards. What is the difference between two is very much logical. I will give one example. Environmental standard is based on treatment technology, and environmental quality standard is based on discharge technology. The concept of discharge technology is not there in India. Now, suppose there are few mirror image companies. They are discharging same quality and same quantity. Assume one company is discharging into one adjoining dry nala. No dilution. Same quality, same quantity, somebody is discharging to some khadi, stream. Minor dilution. Some company is discharging into river, next estuary, next coastal discharge. Right? Everywhere dilution factor is different. Ambient has their own capacity of assimilation of organic compound. That concept only European countries are accepting. Not a single Asian country is accepting this. I will say, coastal discharge. There are two types of coastal discharge. One is at intertidal zone and second is subtidal zone. Intertidal zone means the line between high tide and low tide, where dispersion is there, no much dilution. Where second is deep into sea and into the deep sea. Are you getting me? Deep into the sea and into the deep sea, where dispersion is instantaneous, dilution is tremendous. Sea has a lot of microorganisms, and sea has its own assimilation capacity to degrade even complicated compounds. This concept is not accepted at all by India, whereas it is well accepted in Europe. Whatever standard you know, I know, is treatment technology. मुझे effluent को इतना treat करके डालना है, that's it. Whereas the new concept is, what should be the quality of effluent so that it doesn't have any potential to interact with the environment. As per example, in Dahej, this Bay of Dahej, more than 10 times analysis is done by NIO, CSM, CRI, NIOT. It is found by each and every organization, government organization. The minimum dilution is 2000 times. And coastal discharge is 250 COD if we talk about COD. If 2000 times dilution is there, and there is it is known as ZID, zone of initial dilution, it is very small, and thereafter RMZ, regulatory mixing zone. Regulatory mixing zone is that zone where regulatory can take sample, right? There, minimum 2000, maximum is very much. Then you divide 250 divided by 2000, how much COD? How much COD? Therefore, in earlier session, I heard that 500 COD is granted on experimental basis. But if instead of 2000, if you consider only 10 dilution, instead of 2000, if you consider only 10 times dilution, then 25 COD, sorry, 2500 COD is allowed. और 2500 COD की बात करेगा तो मुझे ट्रीट करने की ज़रूरत ही नहीं है. Of course, I am very much clear, discharge technology is a supplement of treatment technology. It is not an independent. But government should take rational and prudent view. Okay? Mode of discharge is how? If mode of discharge is in marine sea discharge, then they should not be so much rigid, because ultimately we are here to protect the environment, not to kill the industry. But this type of concept is well accepted in Europe. In our earlier session, somebody has told 4,000 COD is allowed, you know. Like that. But this type of concept is not accepted in India. Therefore, it is my kind suggestion that there should be a rational amendment while fixing the environmental standards. Thank you very much.
Thank you, sir. Thank you, sir.